So these papers that we're looking at right now are designed to get you to finding the percent composition of nutmeg oil. The other thing you want is you want actual literature data for IR, right? You want the actual literature IR and melting point rather than just having to use the. Sorry, I'm recording again. Rather than actually having to use just the numbers from Sigma Aldrich. So what you should do, because you're probably going to want to save this list of journal articles so you can go back to it, right? Go to where it says Refined Journal 29, so you're seeing those 29 references, and you'll see at the top there's a thing that says Save that allows you to save an answer set. I can't save this because I've reached the maximum number of saved answer sets. I'd actually have to go through and delete some of my saved answer sets. But you can click on that saved answer set and give it a name so you can very quickly get back to where we are now rather than having to go through Trimyristin, Nutmeg, and references and refined by journal and refined by English. So save that set of references and then we'll go through and we'll actually look for the IR data and I'll show you how to get to that. Cameron Bush, you should stop streaming because your internet connection isn't fast enough and it's giving just a circling boxes. There you go. That works. That's probably interfering with some other people's ability to see the stream. So once you have that data set saved, go back to Explore and under Substances, choose Substance Identifier. If you have the CAS number, the Chemical Abstract Service Identifying Number for trimyristin, you could type that number in there, 555-45-3. You could also just type the word trimyristin in there. And that will pop up this single set. So I'm going to ask you to go back to the general text challenge and give me a thumbs up when you actually have that one compound in SciFinder, the 555-45-3. Sorry that there are pauses. I'm actually trying to communicate with a couple of people whose feed isn't working in private channels as well. So, okay, it looks like most of you are there. So that's good. So if you click on spectra under key physical properties, it automatically takes you to experimental spectra, and it takes you initially to proton NMR. You don't want the proton NMR, you want the IR. So you're going to click on where it says IR, and you'll notice that it says C spectrum, and it actually gives you the AIST spectrum. That's the same AIST spectrum that you got from the AIST database, and then it also says Biorad. So you could click on C spectrum, and that's another source of spectra. But the Biorad spectrum, if we take a look at it, right, that's just the spectrum. It has the peaks. You can match it and say that it looks very much like yours, but it doesn't actually have a list of peaks. So feel free to print that if you want and include that along with the Acros and the AIST spectra when you upload for the IR spectrum. But it doesn't really give us what I want. But what you do see is that references 8 and 9 down there, those two references should list a set of IR peaks. One is from Chemical and Pharmaceutical Bulletin. That is a Japanese journal, but it's published in English. And then the other is from the Chinese Pharmaceutical Journal, and that is actually also published in English. So you could click on either of those references and go to full text access, and that should allow you to get that paper. The Chinese Pharmaceutical Journal you'll find is one that we don't have full text access to. So I have actually interlibrary loaned that, and that one is available to you in the papers from interlibrary loan. So you'll be able to get to that paper. And then there's the my SciFinder has just crashed. There we go, it's back. Right, but the Chemical and Pharmaceutical Bulletin, I think you'll find that we do have full text access to that. You should be able to access that paper. Right. So one or both of those journals will probably be a good source for the IR data that you're going to be reporting when you write your lab report next week. Those references also have melting points. So if you click on the little arrow to the left of experimental properties and then click thermal, you'll notice it gives a whole bunch of different melting points. Right? And you'll notice that there's a boiling point as well, 311, that's not helpful. You'll notice that two of those melting points, 68 degrees and 67 to 68 degrees C, seem to be way out of line with all the others, most of which are between 55 and 58, right? When you see that, those are probably not reliable melting points. They may not even be the right compound. And then you also see a 32 and a 33 melting point down at the bottom that says polymorph, right? So that's not a pure compound, right? Generally, when you're looking up a melting point on SciFinder, you want to look for the one that seems to be most prevalent, right? 56 to 56.5 degrees, that's a pretty accurate number, right? And if you look down there, reference 8, the Chemical and Pharmaceutical Bulletin, that's actually there, right? Reference 8 reports the melting point of 55 to 56 degrees, right? That's probably where Sigma Aldrich got their melting point. When they say Sigma Aldrich and they say literature, it's probably there that they got it from. And then you look at reference 9, which is this Chinese Pharmaceutical Journal. Reference 9 reports the melting point of 67 to 68 degrees C. that is suspicious. That melting point is significantly higher, like more than 10 degrees higher than kind of everybody else's melting point. If you read through that journal and you look at what they're reporting, I consider it highly likely that that melting point is not of trimeristin, that they are in fact reporting something else other than trimeristin. So when you get a melting point that's inconsistent with all the other melting points, you really kind of want to be a bit suspicious. Okay, I am recording, so there'll be several screen recording videos up on YouTube as soon as I get a chance to upload all this stuff that you can watch if you are cutting in and out and missing things. So hopefully you'll be able to get it that way if you couldn't get it live. So I'm going to sign out of SciFinder now. Because I think I've given you everything you need. And I'm just going to go to Google here. And just give me a second, I have to respond to someone's comments here. Alright, so hopefully you're still with me and your crap is not crashing and burning. So sometimes Google is a good source of information and you'll get different papers through Google. As it turns out that if you search for percent trimeristin in nutmeg in Google, you will get all kinds of stuff. You'll get a hit here, 20 to 25%, right? Trimeristin makes up between 20 to 25% of the overall mass of dried ground nutmeg, for all about drugs. And then there's Wikipedia, and then there's Chegg, and there's all kinds of other things. But unfortunately, all of those are taking it from the same place. And they're basically just copying and pasting the Wikipedia thing. If you keep scrolling down, you'll see that there's the Journal of Chemical Education from 1971. That's one of the articles that we saw when we searched in SciFinder. And then you'll see Lab 3 Post Lab. This is somebody just uploading their answers to lab questions. You'll see this sasupenn.edu experiment 6, right? Westminster.edu extraction of trimeristin from nutmeg, chem at umass.edu. So an awful lot of these hits that you're getting are just other people's lab manuals, right? There's a video that tells you how to calculate percent recovery in case you have no idea how to calculate a percent recovery, uploaded by Professor Heath of whatever university that is. University of Toronto does this lab, right? Audinity, right? That's almost certainly just another copy. This one from Course Hero, right? So that's all kinds of stuff that's not very useful. So it turns out the percent trimeristin in nutmeg is not a very good way to search in Google. But if you search for triglyceride composition of nutmeg, that turns out to be a better way to get what you're after, right? The fatty acid composition of the triacylglycerol, the major lipid component, was found to be made of myristic, palmitic, lauric. So this article here, effective gamma irradiation on the lipid profile of nutmeg, that may well be an article that is worth looking at. And we do have full text, right? That's from the Journal of Agricultural and Food Chemistry. We actually are probably able to get that journal. But you'll notice that the PDF thing is blacked out. It says access through your institution. So we can't get it from here, from Google, because it doesn't know that we're an Ohio Wesleyan person from here. What you would want to do is you would want to go back to SciFinder and then under journal, type this information, right? J. Agric Food Chemistry from 2003, issue or volume 51, page 6502 to 6504. You can actually get that directly by searching under research topic, or searching not under research topic but under journal, and typing in the journal information directly. So you'd be able to get that paper, and it's a good one. And then if you keep going down, you'll see that there's a hit under here that says www.fao.org, the Food and Agricultural Organization. That is a good paper. Right. That's a working paper from the Food and Agricultural Organization of the United Nations. And you will find in there information about the percent composition of nutmeg if you download that paper and then scroll through. It's fairly late, right? Right. The description of the components of nutmeg is on page 6, right? So you'll have to look fairly carefully to find the data in that, but that's a good paper. You would find that, I think it's on either the 3rd or 4th page if you search in Google for trimeristin, percent trimeristin in nutmeg, but you get it much quicker by searching for triglyceride composition of nutmeg. If you click on the Wikipedia article, right, they tell you, right, here trimeristin makes up between 20 to 25% of the overall mass of ground nutmeg, and they give those references, 8, 9, and 10. The isolation of trimeristin from powdered nutmeg is a common introductory level of college organic chemistry experiment. References 8, 9, and 10 are, in fact, the 1971 and 1990 and 2002 Journal of the Chemical Education. Those are the references that were listed in the search that we did under SciFinder. So you can't get to them directly. If you click on one of these DOI numbers, it will take you to a page that asks you to pay, right? That says, you can download this PDF, but then I think it will ask you to put in your, access through the university, access through the institution. So we can't get there from here because it doesn't know that we're an Ohio Wesleyan student and we actually have a site license. But you can get to those same papers by typing in the journal directly in SciFinder. So sometimes you can get to a reference through Google and then use SciFinder to actually obtain the full text for that journal, because when you access it directly through SciFinder, it knows you're an Ohio Wesleyan person, and thus you actually should have complete access. So Wikipedia is not a source you ever want to cite, but it is sometimes a useful secondary source that will get you to the references you do want to cite. All right, I'm going to stop this recording.